the last in our series of webinars with the Cadac group. Myself, Johnny Clay, and also we've got Mark in here today, who will be able to give us some great insight. So just to give you a bit of information about Cadac, we are a Autodesk Platinum partner, operating out here in the UK and across Europe. Anything related to Autodesk, design automation, anything along those lines, please get in touch. You see my details down there. Best way to get in touch probably via the website, and there's contact details there. There's even people to chat to you on a live function, which obviously is very of the world that we live in now. But please do get in touch. We can help you with your process regarding digitalization, anything that you're looking to do regarding Autodesk, and yeah. So I shall pass across to Marc Pattinson, who shall now look into the art of design automation. I don't think it's going to be a particularly long one today, sort of around 20 minutes, half an hour from what I've heard. So we should be able to get things done. As per our previous webinars, any questions, please put them in the chat throughout, and then we shall get to those at the end. And I shall now pass across to Marc. Marc, please fire away.
Great, thanks, Johnny. Can you see my screen okay?
Yep, see the screen.
Perfect. Okay, well, firstly, I'd like to thank you all for joining me on today's webinar for the art of design automation. As Johnny mentioned earlier, my name is Marc Pattinson, and I'm technical service consultant based in the UK and Ireland. A little bit about myself, first of all. So I have 14 plus years in the Autodesk channel, generally working with the product design and manufacturing collection. Have some unique skill sets also in the advanced manufacturing market. PDM and PLM, as you know, you can't just be a one-trick pony. You've got to know the industry and dabble in a little bit of everything. But these are my main topics. Personal life, I've been a RNLI crew member now for over 10 years. I'm a crew member, as I said, also a mechanic, so making sure the lifeboat is ready for service all the time. So that does take up a lot of my spare time. I'm also a training coordinator and assessor on station as well. I do dabble in a bit of sailing, so yeah, midlife crisis, bought myself a little sailing yacht in lockdown, and I'm not so good at that, so give me 2 engines any day. But sales, it's another matter, it's another technique completely, but I'm getting there. So today's agenda, we've already done the introduction about myself, so the boring bit's done, and we can move on to the exciting bit. So that's going to be design and automation in Inventor iLogic. So hopefully you have heard of iLogic if you joined this webinar. If not, don't worry, I'll explain a little bit shortly. Now, what I am going to do, which is slightly different to normal webinars where you're watching videos of the application, because it's, things can go wrong, it's live, you can do typos, etc., especially when you're doing a bit of coding. But I am going to do some live examples today. It may take a little bit longer than just running through a very short video. But as I say, it's going to be live, and the reason I'm doing this is because there's quite a misconception of iLogic and coding, and it's for the developers. It's not for me. I have all my models created already, and it's going to take me too long to implement iLogic. So that's my real aim here, to show you that it's actually not. It's designed to do that. It's designed to be added to already existing models. So stay tuned for that one. So it might go wrong, it might not. Fingers crossed. So we're going to start off with captions. You not know what that is, but it's just a funny one to start off with. And then we're going to look at parameters and iLogic forms, which is generally what a lot of people use iLogic for now. We're going to show you a fully configured iLogic form. So yeah, I'm going to play around with a very quick example and then show you what it could look like, Blue Peter style. And then assembly components, how iLogic can handle assemblies inside Inventor as well. It's going to be very, very important. And there's a lot of new additions in the last few years, which makes working with assemblies and iLogic very, very easy and doable, especially even if you're not a coder. And then a little bit of drone automation. So that was brought in on the probably, I think it was the last release. I can't remember which service pack it was, but we're going to do a little bit of drone automation. So you create a component, click a button, and it creates the drones for you. Ish. And then it would be criminal actually not to speak about Autodesk Forge on this, because it is about automation. So Autodesk Forge is the new web platform that Autodesk released a few years ago. So we'll touch a little bit on that as well. And then we're going to finish off with a Q&A. So yeah, get your questions sort of stocked up for the end, because I really want this to be a little bit more interactive at the end if possible. iLogic. For those who don't know what iLogic is, it's a simple way to control complex design variants and automate tedious design tasks, and it does do that. It does. It's a rule-based system, but you really, like I mentioned earlier, you don't need any programming expertise at all to use this product. I don't. I've been using it for a few years, had a break for a few years, come back to it, and it's like riding a bike. There's things you forget, there's things you get wrong, but it doesn't matter because it does prompt you straight away if you have a little error in your code, which you'll probably see on this demonstration, so don't worry about that. And then it's basically putting more design intelligence inside your models, and it's going to make your job in your life a little easier. And of course, if you didn't know already, it's included with your Inventor Professional subscription at no additional cost. So I mentioned also earlier about the misconception of not being able to put iLogic into or include iLogic into your existing models. It's going to be too time consuming. It's going to be a laborious task. That's not the case. You know, it is actually the preferred way of working. You can do some little bits at the beginning when you are designing a brand new model, which makes your life easier, like things like naming your parameters, etc. But even if you haven't done that, it doesn't matter. So yeah, as you can see here, you would create the model, create all your geometry. You would then create all your rules and your conditional statements, which you'll see shortly. You'd save the rule. Now this rule can be used on a network share, if you like, you know, on your local computer, so that you can apply these rules just by importing them onto your models from any location. So it's not just inside the part or inside the assembly, although the examples I'm showing today are going to be that, or just that. And then event triggers. We're not really going to cover event triggers, but it's very straightforward. So let's say, for example, you want to create a PDF of all your drawings on save. The save is the trigger, okay? Or you want to, once you adjust a setting inside your model, it will action another rule, which will action another rule, which will action another rule, and that is sort of an event trigger, okay? So what are the outcomes for you? Well, on the small scale, you can save a few minutes per model. It can do things like checking your model. So if you make a change which doesn't conform with your standards or the industry standards, you can get a little message pop up and say, nope, sorry, too thin, not going to be strong enough, wrong material added, etc. And those are little tiny tweaks, and it takes seconds to implement. Other things you can do. You can also use iLogic as almost like macro-like. So if I change this, then this will happen. Now those are really the grips of iLogic and what it's designed to do. It's designed as a design checker. It's designed to just give you the options which are suitable for your component, your part you're making, or your assembling instance. But on the big scale, and you'll see in a second how much you can actually save. If you're putting this into an assembly configuration and you have multiple different design iterations that you need to choose from, you can actually save hours. You can create forms, so anybody who actually doesn't use Inventor can open up the Inventor software and make changes to a model, hit publish. They've got a full set of drawings and their configuration which the customer has asked for. And the large-scale drone automation, again, is a big time saver. You can have from one assembly, you can click a button and it'll go off and create a sheet for every part, including design, detailed views, dimensions, and give you bill of materials, create an assembly overview, and do all this and put it into a PDF for you. So those are the big time saving things you can do with iLogic. The main part of iLogic we're going to be using today is the rule editor. Okay, it's quite scary when you first look at it, but it's split down into 3 sections. So you have the snippets browser on the left hand side, and what this does, it allows you to pick very easily what you need to include on your model. So just by double clicking one of these, say for features, double click color, it will put how to access that particular property. You've then got the model tab. So the model tab is the model you have open on the screen. You can load models in, but this model browser allows you to go through and look at all the parameters you have within inside your model, any parts, etc., and find out exactly what parameters, what you've called things, so that there's no mistypes, which again I'll probably do anyway in a little while to show you what would happen if we did that. And it just makes life so much easier for you. So again, this will pull up your existing models into this system, so you don't really need to know what things are called, where things are situated, etc. Excuse me. And then you've got the code editor. Again, this is the scariest bit, but it's so easy. And the way I use it is easy. There's no, I'm doing really complex actions and rules, but with very little coding. Okay, and that's the whole purpose of today, to show you how you can do these real advanced features and functions and with very little effort. So the actual design automation, it starts basically on this workflow. So you'd start off creating your parameters and your equations first, as normal. You would then add any driven dimensions, parameters, etc. And you can do this with Excel, you can do this inside your model, whatever's easiest with you. And a very good way to do this is using iParts and iAssemblies and iFeatures. In 2022, I don't know if anybody's using this yet on the call, but the 2022 has what's called model states now. Okay, and iLogic is fully compatible with model states, so you can switch between design iterations at a switch of a button, or using a form, which we're going to go through shortly. But we are looking at iLogic today. Okay, so that's our main focus. The next level to that will be the VBA and macros and API programming. This is when you can make Inventor sing and dance and make a cup of coffee. Yeah, so this is when you need to be a coder to actually work. However, saying that, I'll touch a little bit on Forge later. You can sort of get away with using Forge and this really intricate programming just by uploading a model and doing a few little lines of code. So Autodesk are really focusing on this area. Now for the demonstrations. Are you ready for it all to go wrong? Cool, follow me. So we'll just open up, first of all, our model on screen. So this is a gripper. Okay, and nothing too fancy about this gripper. Built up as normal. I've done nothing to it, just a standard model. And this model has a list of many parameters which haven't been named. What I have done is just change one of the parameters, and this is the one we're going to be using, and I've called that hub, just so we can identify what that is for me. We're going to make that a key, so again, I'll leave it all on at the moment, but by making that key, that makes it available for us to use in other areas. Again, just let me know if you have any problems with seeing what's on screen, or it's delayed or anything like that, because over the web it can be. So we're going to start off with, we've got that hub dimension, and we're going to start off with iLogic Forms. Okay, so in iLogic Forms, so to get this browser up there, you just click this plus icon here, and you can just say iLogic. Then into the forms, this is the easiest thing you can do with inside iLogic. Add form. And because I made that a key parameter, you can see I can just drag that across, and now I have that parameter on a nice pretty form in front. Okay, I can then either use this form and type in the dimension, which will drive it, or I can do things like add sliders. So rather than a text box, I'm just going to add a slider I can then go into the slider properties and change this to whatever values that you require. So we say we could have it going up to 16. We want it to start at 8, and we want increments to be 1. Very easy like that. And then all you need to do is open the form, and again a trigger would be on open of this document, this form will appear. That's a trigger which we talked about earlier, so that anybody who doesn't use Inventor can come in and grab this and just drag this slider, and as you can see it'll open and close, and that is just a dimension. Nothing fancy, nothing too complicated about that. Now we're going to get in a little bit more of the coding side of things. So let's go into parameters again. This time we're going to add user. So there's 2 types of parameters which hopefully you're aware of, is the model and the user. So we're going to create some user parameters here. So the first one's going to be material. Again, I told you I'd make a mistake. First one will be holes. And I could have just left that in there, but you'll see why in a minute. It's going to be unitless, and it's going to be 4. So that means that there's going to be 4 holes on here. And then change it to text. And add material. Add another text to type. And we'll just do size. No, we'll do more for this one. And then through here, what I can do is, you've probably seen this before, but you can add multi-value. I could have one value in there, but why not make it a multi-value? And we'll set the material. If you get the namings correct at this stage, you don't need to do any additional mapping. So if you spell them correctly, hopefully I have, and click OK. So now I have a multi-value in there. Okay, I'm going to do this for type. I'm keeping this very simple. You can be more descriptive if you wish. You'll notice that I'm using lowercase as well. It is case sensitive, so you've got to be careful of that. And then we'll do small and large again. Again, see, follow my own rules. There we go. Add. So we've got small and large, small and large. Okay. Now I am now going to do these as key. And you can do a filter. So all you can see now is the actual parameters which you want to use. And then we're going to go into the iLogic rules. So the first thing we're going to do is we're going to look at the holder. Okay, and this, first of all, just go through this. What you've seen earlier on the PowerPoint is you've got things like the snippets here where you could go through and select these. So if I was wanting something to do with my eye properties, I could go into here and I could find the material, and I could do the component material, which I'm going to do in a second. Double click it and it will all appear on here, which we'll do in just a while. Then we've got the model browser. So this is the model I have open on screen. We'll go into the holder, click on model parameters, and you can see now in this model parameter side of things, should have holes in there. Oh, sorry, ignore me. Yeah, I told you it's gonna go great. So it's this plate I'm wanting. So there you go. So number of holes. So with this, there's obviously a bit of coding involved in this, but all I need to do is just double click the number of holes. Okay, so what that's done is it's now connected from top level a parameter which is in the part adapter plate and I want to equal that to my holes. Again, I'm typing this in. However, if I didn't want to type it in, I could go to my user parameters and just double click it. Okay, so it's really, really powerful in that respect. So the next thing that I'm going to be, actually we'll just show you what that looks like now. Just going to kill my camera, there we go. Right. So now we'll put that into the form. So we'll go back to the form and we can just edit that at any time. And put the holes on there. And again, click OK. And now if I put A in here, there you go. So it's just going to update how many holes we want. And all that is a pattern. And we're just controlling the pattern of holes. Okay, so again, very powerful. So let's go and do a little bit more coding now. So again, you can do multiple rules, or you can just keep editing the same rule. Sometimes it's easier just to separate these, I find. Now this is where it gets a little, you need a little bit of coding experience, but not a lot. We have it all here ready for you. So if we go to if, then, and end if statement button here, you'll see it'll appear on my system. We can indent it, you don't need to. And then you can say if type, okay, so that's the parameter name. Again, let's have a look. I keep forgetting I need to show you what I'm doing here. So if type, so I could just click that, if type equals small, yeah, then, and then for this bit, we just need the parameter length from the actual gripper. So again, going through, length, holder length equals, then a value. Again, not really bothered what it is. But if it's not small, then I need to just put else. And then rather than having to do all that again, I can just copy and paste that and say it's going to be 60. So what I've done there is, if I've selected small on my type, which is that one, then it will be 40. But if I select large, it will be 60. Okay, very easy, honest. But again, this is recorded, so you can look back through it if there's any issues. Now, I mentioned earlier about the materials, so you can go through and just select the material of a component. Again, I'm not doing any coding, so you find it. The hardest thing in this is searching for stuff. It's not really hard, but just type in material and everything will come up. So by clicking that, say material, and then I can get rid of part 1 because it just puts a general one in there. And then the adapter plate, go to the names, double click the adapter plate, puts it in there. And then I want this to equal material, which again, it's all listed, it's all, it all comes up, which again is that. Okay, if I put in material, see how it's brown? That's because it's case sensitive, like I mentioned earlier. So with what, 10 lines of code? Not even that. Okay, so 8 lines of code. I've made this model now a little bit more intelligent. So save and run. If you have an error, then it'll pop up. And then we just need to make this form a little prettier. So we'll just go into the form. We can add the material. We can add the type. We'll not do the motor just yet. Click OK. Actually, hold on. to make it even better. And then you've got a toolbox of things down the bottom left here, so you can just drag it up and we'll just put it there, and then we can add a nice pretty picture to our form. Yeah, you can change colors of the form, etc. There's so much you can do with it. When you change this, you can change the image, so you have a rule to do that and switch images around so it looks like the one you're using. And then we're not going to get into that. So now I've got the gripper, I've got the type, so you can see the gripper arms change, and I've got the color, the material, sorry, all working together and seamlessly. Now, yeah, it took us a little bit longer than usual to do this, but that's because I'm trying to explain it. So yeah, very, very quick to do. Now, another thing to do as well, and I don't know if you know about this command, but it's the save and replace command found. You'll probably see it like that, save and replace. What we can do quite easily is we can select our small motor. Actually, we'll go into the coding first because I'll make it easy for myself. So we'll edit that rule. Actually, let's do another rule so it's separate, so it's easier for you to follow. And we'll just call this one motor. Now, this is when it does get a little bit more coding, but you just put this application. The dogs came to say hello. This is sorry. You can do that, but it's best if you do this assembly dot begin. Again, it's coming up, so I want to begin the manage, and then we'll just do the same again. And this is where we're going to end the manage. Okay, so that's just allowing me to change the assembly, if you like. Okay, and these commands are all, if you go into here, it'll show you these commands which I'm typing in, so that you know it's pretty easy to do. If you manage components, so it tells you here if you want to manage components, you need to the begin manage and the end manage. Yeah, so it's all then tool tips, and then we're going to just do the if. So if, and I need to get my user. So if motor equals, we'll do large this time. Ooh, it's large. Now it's brown because it needs the speech marks. So I've got large. So if the border equals large, then we're going to leave that one. Okay, and then it's going to be slightly different now. Then we'll do the else first. And you see it's exactly the same as the code I've just done. So, you know, now this is where it gets interesting. So if it's large, then I'm wanting a large motor to appear here. Else, if it's small or any other setting, it's going to be small. Now, you don't need to worry about code here. You just need to go right click and capture the current state of what that part is. And that's all constraints, placements, etc. It's all that. Okay. So now we're going to save that. And then we're going to go back to the model. And we're going to use the save and replace, which I mentioned earlier, which is under this productivity bit. Save and replace, and we're going to call this motor underscore. Oh, we've already got one there, so I'll replace that one. Large. Yeah, and then I'm going to just call this one large. Yeah, so now that's called large part. Okay, motor underscore large, and then we're just going to edit that as we would normally in any part or any country. You could do this with a parameter, which would have been a lot easier to mark, but never mind. There we go. And we'll just finish that. And we'll just change the color just so you can see a little bit more visual on that. So we'll just do light red, for example. Okay, so that's our large motor. So all we need to do now is we need to go back into this motor rule. And if large, then, and all I do is go down here and say capture. Oh, is that spelled wrong? Haha. Not that it matters, but we'll larger. Oh, that's better. That would cause you issues. Well, it wouldn't if I selected that one, that's fine, but yeah, if you're trying to reference it later on, it would. So capture state, and that's it. So all I've done there is I've created this assembly begins, did the if statement, which we did before, and all I've done is capture state on two different components. Yeah. Save and run. So now, if I change the motor type to small, you should see in the background, it updates, and on the form, we can add that across very easily to switch between the two. But they're not only that, everything works together, you know, and that's what you want. Okay, and just to show you this in a little bit more detail, here's one Blue Peter style we created earlier, which has a form in, and yeah, it looks pretty similar to what I had, but what you can do is you can change the distance, you can change any parameter what's in here. So we can 2500, it'll automatically change on there. We can do things like add switch buttons, true booleans, so we can add jockeys if we want. We can say that's going to be off-road or on-road, so we give bigger tires. So, you know, the common question is, oh, we don't create anything what's the same. Nothing's similar to what we do. Well, you know, this isn't similar. Everything on this model can change. Load widths, do you want it heavy duty or light duty? You know, so it puts a stronger bars, etc. in, and all it is parameter driven, switching components around, and as you can see on screen there. I did go a bit longer there on that one than I liked on the last example, but hopefully you found that a bit useful. So next is more into detail of switching and constraining components. So I'm not going to talk as much on this one. I'm going to try and whipple through this as quick as I can. But what we've got is we've got a filter here, which needs to basically constrain to these two pipes. But we have multiple types of pumps that we supply to the customer. So the pump, so when we have orders come in, we need to be able to switch easily the components and everything in the model to update accordingly. It's a very simple idea, but it should work quite well. So we'll just open this up to make it easier to understand. Now, what you may have not seen before is we've got what's called an entity name now. Okay, so with this entity name, we can say things like filter in, and this is so we can identify it in our iLogic code. So that's going to be filter in, and that's going to be filter out. Now, just think of how long it would take you to constrain this in the model. You know that, yes, it's not going to be as quick as constraining, but it's not much different. So that's all I've had to do on that particular filter. Okay, I'm going to close that off. So now we have the filter like so. Then I'm going to go here and I'm going to just say again, same principle. I'm just going to put that's the in pipe. And this is the outlet pipe. Okay, and now by adding those to there, that means that when we're using iLogic, we can now call on those tasks, and that would then help for that. 2 seconds, my mouse has just decided to do a wobble. Now, if we go into the iLogic code now, again, Blue Peter style, we have a few things already commented out here. So again, if you don't understand what you're doing or somebody else has done the code, then it's always worth putting comments on there so that people can understand what you're doing. But by commenting something out, it means that it's not going to be actioned. So we'll action these in a second. Then we set the directory. So wherever this document is saved, it will look at that directory. Okay, that's the path it's going to start in. That's equals to dir. And then we're going to look for filters in that directory, but in a subfolder called filters. it's going to be the filter type, which is going to be listed here. So the filter type in a minute when we turn that on, plus IPT. Okay, that's all you need for now. We're then going to start disassembly shenanigans again.
Seem to have lost you a bit there with regards to sound. Not sure if it was everyone else, but I seem to lost like the last thing you said there.
Okay, just
yeah,
the
literally
last
just
thing,
like
yeah?
the last sentence. Yep, I can hear. It's all fine now.
Can you hear me? All right, okay. Right, okay. I think I just said my mouse had gone a bit funny, but the yeah. So all we need to do now is just start this shenanigans here, which is disassembly, begin, manage. Yeah, again, you can just do open close brackets and that does everything. So you can do, basically lets you do anything with that. And then again, disassembly. I always start with this when I'm managing an assembly, so and that's the hardest bit done, really. Well, what I think is the hardest bit anyway. And then all we're going to do now is add a little bit of code in here, which suggests, again, I'll tab it in just so it looks a bit neater, that components you need to be able to spell as well, which I struggle with sometimes. Add there you go. See, it's difficult when you're doing it live, sorry, but that's that, you know, you're seeing it in action, so it's great. And then this is just knowledge, really. There's nothing else I can do with this other than, you know, you could go and watch it back. But what I'm doing is I'm setting now that my filters is going to be picked up by the property filter file name. Okay, and you'll see what I'm doing in a minute. So filter is going to be picked up by, and again, it's, why don't you just go and select what you've got, and then you're not as likely to actually to fail. Well, I probably will at some point, but hey ho. So that's now filtered file name. Okay. And then that's the managing bit done now. Now what we need to do is specify what we're going to insert in our assembly. So if we have a look now at where is it? iLogic, there you go. I've lost where it is. I had it open before, that's a problem, and I went and closed it, but there you go. Sorry, it's relationships. So yeah, you have the classic relationship, which is the old joints, etc., which you can still put them together, but you've got to name your constraints. This is a lot easier. So underneath relationships, I could have just searched insert there and I would have found it easy enough. But again, just double click. And what that does is it will add in the insert command for me. Okay. Now for this one, what I need to do is I need to specify first the name. You can call it whatever you want, which part it's going to use. Okay, so again, we're going to use the inlet valve, and I've carefully named these I and O so I don't get them wrong, but I probably still will. So you just click on those and that'll put it in there. And then what entity am I going to do? So that is going to be the in. Remember we specified that earlier. And then which part? So this is going to be filter. Which is specified up here. And that's going to be filter underscore in. Sorry, that was. I'll just go in. There we go. So you notice there I paused for a little while because all of this turned green. So I put in an extra, I think I did that. Yeah, I put an extra quotation mark in there, which is never good. Let's just comment this one out for now. So again, just do that and then save and run. Wow, look, it's sort of worked. Yeah, sort of. Don't worry yet. So that's all. That's done the first one. Okay. Now what it's done is it's not kept the axis or where we want it to be placed. So it's actually moved everything. So what we need to do is a true relationship to that pipe. And then if we do this in here, you'll see that there's an option to axis opposed. We want to do true rather than false. And as you can see now, the pump is placed. Now if we go back into the edit rule, we now need to put this one on. And we're going to have to be careful here because I do this all the time, is making sure we call this something else. Okay. In fact, I might just delete this one and make it nice and easy. Is copy, paste, insert to. This time it's going to be out, and it's going to be out. Yeah, save and run. Oh man. No work feature or named any with the same out was found. Go do a lowercase, see again. Oh, there we go. See, even the pros can get it wrong. So I forgot to change the part. There you go. Way. So again, you press it, doesn't work. Just keep trying it. Yeah, play around with the code. Don't be scared. You can't break it. Well, famous last words. So now that's actually placed on there, and I'm talked too much, so I need to quicken this up a little bit. Apologies. But I hope you find it useful. So now what I'm going to do is add these commented out ones. So actually, before I do that, if we have a look at the parameters first of all, you'll see that there's only one filter in there, which is the one we have on screen. If I then go into parameters, into the iLogic rule, you'll see that they're all listed in this list. So I'll just quickly go through like so, save and run. And now if we go into parameters, it adds them all in. So it's a very quick way of adding multiple parts into your assembly. Now I already have a form. This is it here, and you'll see the pictures change, which I've got to actually switch as it goes, and we now should be able to just place any configuration, and there's no hidden tricks here. That is exactly what I've just done live with you now. This one's quite a big unit. It pulls it in. As long as they've got that filter in and filter out constraint, it will move your assembly as predicted. So I hope you found that one useful. Now, one more to show you on this. I did think it was only going to take 30 minutes. Sorry, Johnny, I did lie to you there. But we've got this now for drone automation. This one's quite a quick one. So we've got a component, an assembly with loads of components in there. And we've got a sheet with iLogic rules built in. And all we need to do is create a new sheet, which will be blank. We have a form created, but I'll just show you. We've got a few rules there, which adds everything to the drone, and then we just hit drone automation and run all. You can make that a bit pretty if you want. We select the component we want to use, and that'll go off and then build multiple sheets. This is just one as an example, but it'll go off and put all the detail views in, etc. So it's very quick and very easy to do. Yes, like anything, you may need to tidy them up slightly, but the time saved there Could you imagine if it went off and created all of the parts independently? It's giving you a full bill of materials, so it's really quick, and that's just been introduced in the last release there, so it's pretty new to us as well, so very exciting. So lastly, we'll just finish off with Autodesk Forge. So Autodesk Forge, 2 seconds. There we go. So Autodesk Forge is a web-based platform which integrates API and custom coding all in the cloud. Okay, so it allows you to basically have all your iLogic models. This is just one user case in the cloud, and have customers or anyone external configure this model, which you'll see in a second, and produce drawings from that. So generally there's 3 stages. So the configure side of things, what we've just done, the sales configuration, the iLogic, and then the automation side of it. Then we'd export that, and what it does, it does all that in the cloud. And then from the export side of things, you can export it as any CAD format, so assemblies, step files, drawings. You can export bill of material, and then you can also generate multiple different design iterations, so design alternatives, model validation, and you can do this very quick and very easy in the cloud. So yeah, it's just another image. Basically everything, wherever you are, on a mobile phone, iPad, tablet, you can access your model, explode it, and do what you need to do. So here's a quick 2-minute video of one of my colleagues, Demir, going through the iLogic form, which you've just seen. So easy to create. That's all you need to do. You create it, put it in a zip file, upload it to Forge, do a little bit of fancy coding. Again, I'm not going into that in too much detail. Gives you all the information. Now this is in Chrome, in Edge, in Explorer's dead now, isn't it? But yeah, you can see a very good conceptual model. It's got all the information about it. You can any options you have within your iLogic locally, you can then upload them to the cloud, and then basically change them on screen and live, and it's a lot quicker and slicker, especially on a tablet. Then you can create your 2D drawings. So we'll create 2D PDFs at a click of a button, again using that drone automation. We can get the 3D model, which you'll see in a second, and we can also do things like add it to our sales process. So we can say we want to request a quote as an end user. So this is the model I'm requiring. It's been sent and then linked with Fusion Manage, or Fusion Lifecycle as it was known. Fusion Manage then gets the notification that a customer wants to actually get a quote for this. We can go through, we can have a look, check the specifications are going to fit with the required needs. Also, it can give them prices, straight up off the bat if you wanted to do that. This login can be obviously authenticated, or anybody can have access to this link in your models. So again, fully customizable on screen. Another quick way is you can build up things like, in this instance, platforms. You can give the customer just a few options, so they can add steps, platforms, ladders, etc. very easily, and generate, by doing that, the 3D model. View it on screen using the Forge viewer, explode it, check measurements, check it's going to fit, it looks okay, of course, aesthetics. We can then download those files and then open it up as an assembly back in the office with a full bill of materials ready to go. So that now concludes our demonstration. I hope you found that useful. There's so much more to iLogic we could go through, but time has beaten us. And obviously leave the floor open now to any questions or anything you have.
Yeah, thanks for that, Mark. Yeah, your idea of half an hour seems to be a bit off, but say la vie, these things happen. Yeah.
What time we're on?
We've got a couple of questions in, so we'll just rattle through these so people can get back to their working day. So Jack's coming in with a question saying, is it just Inventor iLogic works with?
Great.
So the question just says, is it just Inventor that iLogic works with?
Clarify that.
So I presume he means, does it do iLogic with AutoCAD or things like that?
Yes. Sorry. Yes. Yeah. Absolutely.
Okay, and then
Yes, it's just Inventor. Yeah. However, you can have it
right,
produce drawings in AutoCAD if required, so you can get it to do additional things. So yeah, API access you would need to integrate that, but again, just reach out with more
brilliant.
detail, and we'll be
And
able
then
to assist you on that. And
Nick
if
said,
there's
how
something
would you
you have
advise
on your
someone
mind or
new
you
to
want to do.
iLogic to start the process? Because I think that from the looks of what I've seen today, anyway, I was definitely quite daunted by the looks of the coding side of things.
Yeah, apologies for that. That's probably my fault and then not explaining it more. But yeah, it's really just get stuck in there. Obviously, there's course available. By just contact you at Cadac, and certainly can run some courses. There's a lot of tutorials on YouTube, and there's also some help files with inside Inventor as well, and step-by-step process. But certainly reach out, Nick, and we'll be able to help you and point you in the right direction. But the again, this recording, try it out. Just go in, pause the video, keep playing it over and over again, and just go through what I've discussed today, and play around with it. It's probably the best bet. Um, and my advice as well is to, before you start, is just have the outcome you require. So you could start doing get halfway down the line and realize it's not going to be suitable for what you need. So just, yeah, map it out first. So you've got your model, what you want your outcome to be. You want when to change parts, you want things to change materials, etc., for maybe simulation, stress analysis, or whatever. And then once you've got your outcome mapped, you can then work backwards and go, right, well, I'll need
Right,
this to work, this to
brilliant.
work, this
That's
to work.
I
So
think that about wraps it
that's how
up.
I would do it.
So thank you all for attending. Like I said at the start, if you have any questions regarding any of this, then please get in touch with us here at Cadac. Find our website, that kind of thing, and go from there. But I'll leave you all to your day and have a good one. Thanks, Mark.